need to make sure that you type that person correctly. And whatever cross-matching occurs, that hopefully is done correct. It was discovered in the early 1900s what could happen with the blood mismatching, all right? And when we talk about the blood, we're going to look at antigens and antibodies. We have learned a lot about this since the early 1900s. When you begin to look at something like Virginia Blood Services, like I said before, when you give that pint of blood, they can now extract it into 3 parts. Okay? That's why they say you could save up to 3 lives. All right? Now, when we have large quantities of blood that are lost, the reason that we need to make sure that it gets replaced is because that can send a person into shock, and believe it or not, by that happening, that can actually lead to death. Okay? And you know, the overall goal, hopefully, of treating something in the medical world is to make sure that that patient's not going to die. Okay? Unless we know it's something terminal. So when we begin to look at this, in the early days, when transfusions were done, reactions were very common because they didn't know everything that we know now. I mean, they would simply have one on one table, one on the other, and a line stuck between them. Okay? And the more we learned, we found out that if there is a reaction to the blood that's being given, that it would clump up, block vessels, and the person would die. Now, does that mean that it's 100% now that we know exactly how to make sure that we don't make a mistake? No, because reactions still occur. But what we have learned is we have learned a lot about the structure of the red blood cell. And the red blood cell, we're going to find that we have these reactions with these antigens and these antibodies. An antigen a complex molecule on the surface of the cell membrane that will activate an immune response. They are genetically unique to the individual. Antigens are also called agglutinogens. What does it mean to agglutinate? Clump together. So antigens, hopefully they'll get used to distinguish self from foreign matter. Meaning, hopefully it will recognize self cells and attack or take care or try to get rid of something that is not a self cell, something that would be considered foreign. So something foreign activates an immune response. The antigens that are on the surface of these red blood cells, that's the basis for blood typing. What do we think of when we hear blood type? A, B, O. Is that correct? We tend to think of the A, B, O blood groups. How many are there total? I'm going to see who's done their reading. Over 100 blood types. The majority of them are just rare. A, B, and O are the ones that are most common. So A, B, and O are what we think of when we hear the blood type. Now, these antigens are going to help us determine that. And the antibodies they're very specific, and they will only bind to one type of antigen. Okay? So these antibodies are very specific, and they will only bind to one type of antigen. Antibodies are proteins. They're termed gamma globulins. So that tells me they're going to be some type of protein structure. And globulin tells me globe. They get secreted by plasma cells, not red blood cells. They are secreted by plasma cells. They help or are a part of the immune response to foreign matter. They can bind to an antigen, mark it for destruction. When they bind to an antigen, they form the antigen-antibody complex. Agglutinins, don't confuse it with agglutinogens. Okay? Agglutinins are going to be antibodies in the plasma that will be really, really bad if there's a mismatch with a blood transfusion. So we had agglutinogens and now agglutinins. Agglutination is when that antibody will bind to an antigen, and for the red blood cells, this would involve the red blood cells, and this will cause them to clump. And if they clump, that's not good. So the blood types, oh, I forgot AB. These are the ones that are most common. A, B, O, and AB. The red blood cells, antigens, are the agglutinogens. They are determined by glycolipids, and the antigens are A and B. Let's go back in our memory for a second. Glycolipid. Sugar. sugar. And what part of this contains the lipid portion? The plasma membrane, because the plasma membrane is made up of what? Phospholipids. So this plasma membrane, made up of the phospholipids, means that that sugar structure is coming off of one of those phospholipids. Do you guys remember that? So, the agglutinogens. Notice they're trying to show us the sugars, galactose, fructose, and galactosamine, all right? And the structures that they have. So we've got type A, type B, and then AB, because it's got both A and B. O, don't have nothing swinging off of it. Antibodies, now note, the blood type structure is on the red blood cells membrane. An antibody can be in the plasma. Two different portions of the blood. So, if we look at a blood vessel, all right? So this is my blood vessel. Out here is all my blood, right? Plasma, white cells, everything, correct? So my red blood cell, all right, is everybody following me? Is out here is where I'll find my plasma. The red blood cell can contain my antigen. So let's say this is my antigen, and it's helping determine, is it A, B, or O? Okay? Now out here in the plasma, if this is going to be, let's say, if that's going to be our antigen, the plasma has created antibodies. So out here in the plasma, that's my antibody. On the red blood cell is my antigen. See how we've got one with the red blood cell, the other one with the plasma of the blood. Because it's going to be plasma cells that'll give rise to the antibody. So this ABO group, blood type is determined on whether you have the presence or the absence of an antigen. If blood type A, you're going to have an A antigen. B will have the B. AB has A and B. O has neither one. The most common type of blood is O. If you go give blood and it's for the first time and they find out you're O, and then they find out you're O negative, they're going to bug you for life. Okay? They're going to want you coming in and giving blood every 6 months, which I think is how often it's supposed to be done. Okay? So the most common, O. The rarest, AB.